The Juno mission was launched on August 5, 2011, and arrived in orbit around Jupiter on July 4, 2016, and our view of Jupiter has never been the same since. Juno is presently orbiting Jupiter. Today's video will go over the Juno mission, how much it costs, and more, so stay tuned. So why Jupiter? Well, scientists say it is the cornerstone of planet creation, since it is the biggest planet in our solar system. Jupiter's massive mass impacts other planets, asteroids, and comets. Therefore, a thorough study of Jupiter will aid in our understanding of other planets. Juno's missions will especially hunt for evidence of Jupiter's formation, assisting in the disentanglement of rival ideas regarding its past. We can't grasp the solar system's origins or how Earth came to be until we know how Jupiter originated. We still don't know much about Jupiter, such as what it's comprised of, what lurks beneath those lovely swooping clouds, what precisely is the source of its magnetic field. Planets like Jupiter were formed early in the process, before their newborn stars had a chance to absorb or blast away the light gases in the massive cloud from which they sprang. Giant planets also play an important part in planet formation due to their massive masses, which allow them to alter the orbits of other objects in their planetary systems, such as other planets, asteroids, and comets. Although scientists have put together the general story of Jupiter's formation, certain critical issues remain, and Juno's purpose is to assist us in answering them. However, Juno is not the first space mission to investigate the big planet. The Galileo spacecraft conducted Jupiter studies for 8 years, until 2003. On the other hand, the Juno probe is unique in that it is fueled only by solar panels, which are more usually seen on satellites circling Earth. The Galileo spacecraft. Galileo was the first spacecraft to conduct a long-term study of Jupiter and its moons. It took off from the payload bay of the Space Shuttle Atlantis in 1989, gained some speed, bypassed Earth twice and Venus once, and finally arrived at Jupiter in 1995. Despite facing multiple technical faults while orbiting the solar system's most massive planet for 8 years, Galileo transmitted back a slew of discoveries to Earth. It detected salt water beneath the faces of 3 moons, Europa, Ganymede, and Callisto. It also came close to the iconic Pizza Moon, right before the last drops of Galileo fuel ran out. NASA had to purposely launch the spacecraft into Jupiter on September 21, 2003, but the sacrifice was not made for no reason. The space agency stated that it was vital for the safety of Europa, which most likely possesses a subsurface ocean that may host life. What exactly is the Juno mission? In Roman mythology, the great deity Jupiter is thought to wrap himself in clouds to conceal his malicious actions. Only his wife, the goddess Juno, could see his true nature through the cloak. Juno, NASA's spacecraft, has definitely lived up to its name. By peering underneath Jupiter's whirling bands, Juno has been able to see the planet's inner workings in a way that no previous probe has been able to do. Juno's mission is to investigate Jupiter's current mysteries in order to better comprehend its history. The probe used a set of very sensitive equipment to reveal new light on Jupiter's tremendous storm systems, magnetic field, and much more. On August 5, 2011, Juno was launched by an Atlas V rocket from Cape Canaveral, Florida. On October 9, 2013, it sailed by Earth for a gravitational boost on its way to Jupiter, where it landed on July 4, 2016. Juno circles Jupiter in a very elliptical orbit, 4,400 by 2,700,000 kilometers, 2,700 by 1,700,000 miles, every 11 days. Unlike earlier missions to outer planets, Juno is fueled by the Sun. Juno's 3 arrays of solar panels are well over 20 meters, 66 feet in length, due to Jupiter's location from the Sun. Juno is equipped with a variety of equipment for studying Jupiter's auroras, magnetosphere, atmosphere, and gravitational field. One of the most notable disparities between the Galileo and Juno spacecraft data is that Jupiter has more water than a prior analysis showed. Its microwave radiometer (MWR) instrument utilized 6 antennas to concurrently detect the temperature of the planet's atmosphere at different depths, allowing scientists to calculate how much water is contained in the gas giant's atmosphere around its equator. At 93 miles underneath the surface of the atmosphere, Juno was able to gather more precise data than NASA's Galileo spacecraft, which was at 75 miles in the 1990s. Scientists were disappointed by Galileo's results, which revealed that the alien world was relatively dry. Water measurements from the satellite spectrometer were 10 times lower than predicted. So you're probably wondering what Juno has uncovered so far. Jupiter has revealed both real and metaphorical new depths to Juno. The planet's fierce storms appear to be more turbulent and exciting than initially assumed. The spacecraft, for example, has discovered a cluster of cyclones and anticyclones near Jupiter's north pole. According to NASA, Juno discovered Earth-sized storms around both of Jupiter's poles. Massive cyclones. New research has discovered that the very same factors that move water in the Earth's seas also produce massive cyclones all around the poles of the solar system's biggest planet. Jupiter's massive polar cyclones, which may be up to 620 miles, 1,000 kilometers wide, were discovered in 2016 by NASA's Juno spacecraft. Scientists have believed ever since that these storms are caused by convection, the process by which hotter air expands and climbs to higher, colder, and denser altitudes. They couldn't verify the existence of this mechanism on Jupiter until recently. Then, oceanographer Leah Segelman, a postdoctoral researcher, noticed that the polar cyclones resembled ocean vortices studied by scientists on Earth. Some scientists examined a series of photographs of Jupiter's North Pole cyclones, recording at infrared wavelengths, which revealed the heat released by an object. The study employed the same methods that scientists use to investigate large-scale air and water fluxes in the Earth's atmosphere and seas. The research allowed the scientists to compute the speed and direction of local winds, as well as track cloud migration. The researchers were able to tell the difference between locations with little cloud cover, from which they could see further into Jupiter's atmosphere, and areas hidden by a dense layer of fog. The Juno spacecraft discovered 8 cyclones near the planet's North Pole, and 5 near the planet's South Pole, all of which are still active more than 5 years later. Intricacy under the clouds. Because Jupiter is a gas giant planet, there's no use in wondering about its surface conditions. It doesn't have one. Instead, the hydrogen and helium gas that make up the majority of Jupiter's atmosphere just gets denser and denser as you descend until the hydrogen becomes a liquid metal. However, there is still plenty of activity in Jupiter's spinning clouds, which are likely to be a mixture of water and ammonia. And, as researchers discovered using a microwave device that allows Juno to explore below those clouds, there are a lot of intricacies beneath the clouds as well. For example, it seems that the east-west winds that are believed to rip through Jupiter's cloud tops aren't merely a high-altitude phenomenon. Winds may travel thousands of kilometers underground. Similarly, Jupiter's famed Great Red Spot, a vortex a little bigger than Earth that has been whirling for a minimum of 2 centuries and perhaps considerably longer. It stretches for roughly 30 kilometers all downhill. Data from NASA's Juno spacecraft's microwave radiometer demonstrates that Jupiter's banded pattern continues deep under the clouds, and the appearance of Jupiter's belts and zones inverts near the base of the water clouds. Microwave light enables planetary scientists to peer far into Jupiter's colorful clouds, gaining insight into the weather and climate in the warmer, darker, deeper layers. The planet's belts radiate brilliantly in microwave light, at altitudes of less than 5 bars of pressure, about 5 times the typical atmosphere pressure on Earth, whilst the zones remain black. However, everything changes at higher pressures and altitudes greater than 10 bars, providing scientists a glimpse of an unanticipated reversal in meteorology and circulation. Confusing core. Scientists have already received fresh insights into Jupiter's core as a result of Juno. In the lack of precise evidence prior to this mission, ideas varied from a core made of heavy components cemented early in the solar system to no core at all. If a core exists, as presently appears to be the case, it is unclear if it is solid, liquid, or both, and layered or diffuse. Due to the enormous pressures, up to 2 million bars of Jupiter's core, that would kill any probe that attempted to reach such depths, there is no method to explore the core directly. Juno instead investigates Jupiter's core indirectly, by detecting its magnetic and gravitational fields. What will Juno be studying at Jupiter? Juno may now explore much deeper into Jupiter's secrets, many of which it has helped to uncover. In addition to the 34 orbits performed during the primary mission, Juno will orbit Jupiter 42 times more during the next 4 years. For the most part, these elliptical orbits arc out wide to avoid the worst of Jupiter's radiation, before dropping in close to get a decent look at the planet. The closest approach point, the perigove, was initially close to the planet's equator, but has been progressively advancing northwards at a rate of around 1 per orbit. Despite the fact that the Juno mission was initially planned to conclude its cataclysmic crash into Jupiter's atmosphere in August 2021. However, NASA gave Juno a remission in January 2021, and the mission was extended until September 2025. So what are your thoughts on this magnificent probe and everything it has revealed thus far? Let us know in the comments area down below.